Hi everyone, welcome to this session on cryptography. This is the video number 8 of the entire series. In total, we have 16 videos for 16 different concepts of cryptography. So this one is based on elliptical curve cryptography. Now, in the previous session, we understood about symmetric and asymmetric, right? And when we talk about symmetric, we have understood about the public key and private key. And then RSA is one of the algorithm which is kind of used for the same, isn't it? So now in today's session we are going to discover another you can say another asymmetric cryptography, which is called as elliptical curve cryptography. Okay, so let's dive into this and let's take this up. So this topic is elliptical curve cryptography. Okay, so elliptical curve elliptical, this is basically elliptical curve cryptography. You know what is elliptical? It looks like something on a parabolic path. So if you remember, the RSA algorithm or most of the asymmetric algorithm, they are based on what? They are based on you can say factorization of big prime numbers, right? That is what we have discussed until today. Even RSA is based on the same. This particular elliptical curve cryptography is another form of asymmetric cryptography only, but this is based on the principle of elliptical curve, or you can say discrete logarithm problem. Okay, now if you are having difficulty understanding this, what is this discrete logarithm problem? Let me tell you in the very simplest way. If you have to relate these two, the factorization and the logarithm problem thing, you can take it. For example, the factorization problem was that day we discussed about 91, right? 91 is a factor of 13 and 7. Both of these are prime numbers, right? And if you use a particular cryptography to do something, it will be the multiple of this particular number or a factor of this particular number. So one becomes the private key and one becomes the public key, isn't it? So this is based on mathematics. Now if we have to see this elliptical curve cryptography, this is based on discrete logarithm problem, which means now we are not going on factorization, rather than we are going on, let's say, 13 raised to the power 7. So 13 into 13 into 13, 7 times, right? You can see this can generate much more powerful and complex you can say output as compared to the fraction problem, because now we are going exponential. This is some form of exponential thing. So that is something which you can relate with discrete logarithm problem. Okay, and in this one what happens is this forms a kind of elliptical thing, and any 2 points on this particular elliptical curve, they are taken, one as a primary key and one is called as a public key. Okay, now the entire security of this particular mechanism is based on the difficulty of predicting these two keys, which is actually on a kind of parabolic path. So that is where this particular kind of cryptography is getting more and more popular today. Why it is getting more and more popular today? The concept is, elliptical curve cryptography, we can generate much more complexity by using very small keys. Smaller keys compared to the other asymmetric algorithms, and we are able to achieve the same kind of output. So that is where, when there are places where, let's say, you have a mobile device where you need to let's say implement this ECC. So that this ECC will also be capable of operating on devices which has very low performance, because just by using a small key you are able to generate the same level of complexity as we were using in like RSA and other algorithms. That is the reason why it is getting now more and more popular than RSA. Okay, even NIST highly recommends using ECC. Now it is getting more and more widely standardized, and it is getting adopted by very common protocols. Like for example, in some cases we also use it in TLS, SSH, we also use it in Bitcoin, and that is how you can see even the certificate authorities, they are also trying to adapt this ECC as a algorithm there in the digital certificate, in the PKI mechanism itself. Okay, now because it is very complex, it's better than RSA, right? Is it also not susceptible to quantum cryptography? That's not the case. Right now, you know, a new concept of cryptography is coming in, which is called as quantum key cryptography. So in that we use huge computational power to you know, break the crypto system and all of this. So if you are using ECC with some kind of low key length, then it is still susceptible to quantum key cryptography. You have to actually use higher length keys to generate more complexity out of ECC to be more you can say resistance to the quantum key cryptography, which is quite a threat in the real world as of now, because the way the quantum computation is coming up, the computing power of systems is getting so much increased. So even that is a threat for most of the cryptography as on today. Okay, so this is the core concept of the elliptical curve cryptography, and you should know all these kind of things from the exam perspective. Okay,